If you dropped Earth into this star, it would be like throwing a grain of sand into the Pacific Ocean. And that's not even the scary part. Let's get your bearings. You live here, Earth. It fits about 1,300 times inside Jupiter, and you can fit about 1,000 Jupiters inside our sun. Our sun feels enormous. It powers our entire solar system. And in the grand catalog of stars in this universe, it's below average. It's classified as a yellow dwarf. Now start scaling up. Sirius, about twice the size of our sun. Pollux, 9 times. Arcturus, 25 times. Impressive. Until you realize we're still playing in the shallow end of the cosmic pool. Today, we're going to the extreme. We're climbing a ladder of monster stars, each one bigger than the last, until we reach the current champion, the star many astronomers believe is the largest known in the observable universe. And along the way, there's something deeper here. These stars don't just stretch your sense of scale. They stretch the way you think about growth, limits, and what's possible. Let's start climbing. First, Rigel. Rigel is a blue supergiant in the constellation Orion. It's about 79 times wider than our sun and roughly 120,000 times more luminous. You can see it from about 860 light-years away with your naked eye. Think about that. Almost 1,000 light-years away, and it's still one of the brightest stars in our sky. Rigel teaches something simple but powerful. Visibility matters. It's not the biggest star in the galaxy. It's not the closest. But it's bright. It shows up. For centuries, sailors use it for navigation. In your own life, you don't have to be the most experienced person in the room to make impact, but you do have to be visible. Share your work. Speak up. Publish. Volunteer for the hard assignment. Visibility compounds. But Rigel is tiny compared to what's next. Now we move to Betelgeuse. Betelgeuse is about 764 times wider than our sun. If you place it at the center of our solar system, it would stretch past the orbit of Jupiter. Earth, Mars, the asteroid belt, all swallowed. And Betelgeuse is dying. It's in the final stage of its life. It's unstable, pulsating, expanding and contracting like a heartbeat. Astronomers believe it could explode as a supernova within the next 100,000 years. Maybe tomorrow. Maybe thousands of years from now. In 2019, it dimmed dramatically and the world panicked. Was this the end? It turned out to be a massive dust ejection blocking its light, but it reminded everyone that this giant is living on borrowed time. Betelgeuse teaches a harder lesson. It grew massive by burning fuel at an extreme rate, and now it's unstable. Expansion without sustainability leads to collapse. In careers, that looks like burnout. Saying yes to everything. Expanding faster than your support system can handle. Every supernova starts with overextension. Audit your fuel. Before you explode. Now we go bigger. UY Scuti. For years, UY Scuti was considered the largest known star. It's roughly 1,700 times wider than our sun, though newer measurements suggest it might be smaller than we first thought. If you replaced our sun with UY Scuti, its surface would stretch beyond the orbit of Saturn. If you try to fly a plane around its equator at normal cruising speed, it would take over 3,000 years to complete one lap. Its volume could fit billions of suns inside it. But here's where it gets interesting. Measuring something that big, from thousands of light years away, is incredibly difficult. These stars don't have solid edges. They pulsate. They blur into space. Astronomers estimate size using angular diameter and distance. A small error in distance creates a massive change in calculated size. That's why newer Gaia data suggests UY Scuti might be far smaller than early estimates. And here's the lesson. How you measure something determines what you believe about it. If you measure success only by salary, you might miss fulfillment. If you measure productivity by hours worked, you might miss efficiency. NASA once lost a $125 million Mars orbiter because one team used metric units and another used imperial. A measurement mismatch destroyed a mission. The wrong metric doesn't just give you bad data. It gives you the wrong life. Now, the current heavyweight champion. Stephenson 2 to 18. This red supergiant is estimated at about 2,150 times the radius of our sun. If placed in our solar system, it would engulf everything out to Saturn and approach Uranus. Its volume could hold roughly 10 billion suns. Light, the fastest thing in the universe, would take over 8 hours to travel around its circumference. It resides in a dense cluster of red supergiants and was only fully appreciated in size after improved infrared measurements revealed its true scale. Even now, its exact size carries uncertainty. It's obscured by dust. It's distant. The error bars are huge. And that honesty matters, because the title of largest star isn't permanent. Other contenders, VY Canis Majoris, WHG 64, have held a crown before. New measurements can shift the ranking at any time. Science doesn't pretend certainty where there isn't any. That's why it works. There's another layer here. Physics. As stars grow larger and more luminous, their radiation pushes outward against gravity. There's a theoretical limit, called the Eddington limit, where radiation pressure nearly overcomes gravitational pull. Beyond that, the star starts blowing itself apart. Stephenson 2 to 18 operates near that ragged edge, almost too big to exist. And that leads to one of the most important lessons of all. Every system has a limit. Every person has a growth threshold. When expansion outpaces structure, instability follows. Growth is powerful. But growth without infrastructure is self-destruction. Programs scale too fast and collapse. Companies grow without culture and implode. Individuals get promoted without support and burnout. The key isn't just growing bigger. It's strengthening the core that supports the growth. And here's the final perspective shift. Every one of these colossal stars, even the largest known in the universe, started the same way, as dust, a collapsing cloud of gas and particles pulled together by gravity. No star is born enormous. It accumulates mass. It builds pressure. It sustains fusion over millions of years. It becomes massive through process, not event. The largest known star in the universe is roughly 2,150 times wider than our sun, and it started as dust. So when you look at your own ambition, the scale of what you want to build, remember this. You don't start as a Stephenson 2 to 18. You start as potential. The real question isn't how big you want to grow. It's whether you're building a core strong enough to sustain the size you're chasing.